Hello students, this is lecture number 6 and we are studying matrices and determinant. So in this lecture, we will study how to find matrix of cofactors and adjoint of the matrix. So firstly, we will see how to find matrix of cofactors. So to understand how to find matrix of cofactors, you first must know how to find the minor of element. Okay, minor of element. So in the previous lecture I have explained how to find the minor of every element. Okay, for example, suppose we have the matrix A which is of order 2 by 2, A B C D. Okay, so in the previous lecture I have explained how to get the minor of every element. Okay, so we can find minor of A, also we can find minor of B, also we can find minor of C, and we can find the minor of D. So the minor of A can be obtained by just hiding the row and the column where A is present, that will be D. Okay, again minor of B can be found using just by hiding row and column where this B is present. Okay, so what remains? C. Also we can find the minor of element C by just hiding row and column where C is present. So what remains? B. Also we can find the minor of the element D just by hiding the row and column where D is present. What remains? A. So this is how we can find the minor of every element in the given matrix. On the similar basis, we try to find the minor of the element which are present in the 3 by 3 order matrix. Okay, now we will try and understand what means the matrix of cofactors. Okay, so we'll see what is matrix of cofactors. Okay, so firstly we'll see how to find the matrix of cofactors of for 2 cross 2 matrix. Okay, so for this, suppose we have the matrix of order 2 by 2, that is suppose given by A11, A12, A1, A21 and A22. This matrix is having order 2 by 2, then its cofactor matrix will be given by the matrix capital A11, capital A12, capital A21, capital A22. Okay, this will be again the matrix of order 2 by 2. Okay, where this Aij, you can see here A11, A12, A21, A22, these are Aij. Okay, this Aij will be equal to minus 1 raised to I plus j into Mij. Okay, where this I is equal to number of row in which the element is present, number of row in which the element is present. Okay, and this j is number of column in which the element is present. Okay, for example, suppose I will say this as Aij, A12. Okay, what this will be? This will be minus 1 raised to 1 plus 2 into M12. Okay, and also this Mij is nothing but minor of element Aij. Okay, now for example, suppose I want to find cofactor matrix of the matrix A equal to, suppose A11, A12, A21, A22. Okay, then as I told you, the cofactor matrix will be given as cofactor matrix of this matrix A will be capital A11, capital A12, capital A21, capital A22. Okay, so by definition, what I said, this Aij is nothing but minus 1 raised to I plus j into Mij. Okay, so what is this Mij? Mij is a minor of the element Aij. Okay, so firstly if I'll try to find this value A11, which will be minus 1 raised to 1 plus 1 into M11. Okay, what is this M11? This M11 is the minor of the element A11. Okay, so this will be minus 1 raised to 1 plus 1 into minor of A11. Okay, so this is equal to minus 1 raised to 1 plus 1 into minor of A11. So what is minor of A11? Hide the column and the row where that A11 is present. Okay, so what remains? A22. Okay, so this will be A22. Okay, and minus 1 raised to 2 will be 1, so what remains? A22. So we got the value for capital A11, which is A22. Okay, on similar basis we can find the value for A12. Okay, A12 will be minus 1 raised to 1 plus 2 into M12, where this M12 is the minor of the element minus 1 raised to 1 plus 2. This is what? Into minor of element A12. Okay, so this is equal to minus 1 raised to 3. Minus 1 raised to 3 is minus. Okay, in bracket. Now see what remains. The minor of element A12. So hide the row and column where that A12 is present. So what remains? A21. Okay, so what will be the value here? A21. Okay, so this will be the cofactor of the element A12. Okay, similar way we can find A21. This will be minus 1 raised to 2 plus 1 into M21. Okay, and this will be minus 1 raised to 3 and M21, that is the minor of the element A21, and that is nothing but A12. So this will be minus A12. Okay, similar way we can find the element A22, which is equal to minus 1 raised to 2 plus 2 into M22. Okay, so this will be minus 1 raised to 4 into M22. M22 is the minor of the element A22. So hide the row and column where that A22 is present. So what remains? A11. So finally minus 1 raised to 4 is 1. So what remains? A11. So we got all the elements capital A11, capital A12, capital A21, capital A22. Therefore the cofactor matrix is what? This matrix A11, A12, A21, A22. Okay, which is equal to the value for A11 here is what? A22. So this will be A22. The value for A12 is minus A21. Then the value for A21 is minus A12, and this will be A11. Okay, so this will be the matrix of cofactors. Okay, or cofactor matrix. Okay, so this is how we find the cofactor matrix when the matrix is of order 2 by 2. On similar basis we can find the cofactor matrix when the matrix is of order 3 by 3. Okay, so second point, for 3 cross 3 order matrix. Okay, so suppose question we will write. Okay, question, find cofactor matrix of matrix A. Suppose A11, A12, A13. Okay, this will be A21, A22, A23, then this will be A31, A32, A33. Okay, so its answer will be the cofactor matrix of 3 by 3 matrix will be this one, capital A11, A12, A13. Okay, this will be A21, A22, A23. This will be A31, A32 and A33. This is a 3 by 3 matrix. Okay, so as I have told you, where this Aij is equal to minus 1 raised to I plus j into Mij. Okay, where that Mij is the minor of the element A11 or a minor of the element Aij. Okay, so firstly we'll find this capital A11, which will be minus 1 raised to I plus minus 1 raised to 1 plus 1 into M11, where M11 is the minor of the element A11. Okay, A11 element is here. Okay, so hide the row and the column where that element is present, and we need to take this determinant. Okay, so what we will get, this will be minus 1 raised to 2 into the determinant. What determinant? A22, A23, then A32 and A33. Okay, and solve this determinant. On similar way, we can calculate A12, which will be minus 1 raised to 1 plus 2 into M12. So this will be minus 1 raised to 3 into determinant. What determinant? What is this M12? M12 is the minor of the element A12. Here is the element A12. So hide the row and the column where that element is present. Okay, so what remains? A21, A31, then A23, A33. Okay, similarly we can find this element A13, which will be minus 1 raised to 1 plus 3 into M13, which is minus 1 raised to 4 into the determinant. Okay, which determinant? Hide the first row and third column. Okay, so first row and third column. So what remains? This determinant. Okay, so what remains here? A21, A22, A31, A32. Okay, similar way we can find this A21, which is minus 1 raised to 2 plus 1 into M21. Okay, so this will be minus 1 raised to 3 M21. M21 is the minor of the element A21. A21 is here, so hide the row and the column where that element is present. Okay, so what remains? A12, A13, then A32, A33. Okay, on similar basis we can find this element A22. Okay, this will be minus 1 raised to 2 plus 2 into M22. Okay, so this will be minus 1 raised to 4 into minor of the element A22. This is the element A22, so hide the row and column where that element is present. So what we get? We get this as determinant of A11, A13, A31, A33. Okay, similarly we can find this element A23, which is equal to minus 1 raised to 2 plus 3 into M23, where M23 is the minor of the element A23, this element. Okay, so hide the row and column where that element is present. Okay, so what remains? This will be minus 1 raised to 5 into determinant A11, A12, A31, A32. Okay, similarly we can find this element A2, A31. This will be minus 1 raised to 3 plus 1 into M31, where M31 is the minor of the element A31. Okay, so this will be minus 1 raised to 4 into the determinant of the minor of the element A31. Okay, A31, where it is? This is the element, so hide the column and the row where that element is present. So what we get, this will be determinant A12, A13, A22, A33. Okay, so this is how we find the we can find the element A31 also. Similarly, we can find element A32, which will be minus 1 raised to 3 plus 2, okay, into the determinant where that element A32 is present. So hide the column and the row of that corresponding element. Okay, so what remains? A11, A21, then A13 and A23. Okay, on similar basis we can find this element A33, which will be minus 1 raised to 3 plus 3 and the determinant and the minor of the element A33. Okay, this is the element A33. So hide this row and this column, the element where it is present. Okay, so what remains? A11, A12, then A21, A22. So this is how we find the minor of every we can find the cofactor of every element, and so that we can find the cofactor matrix of the given matrix. Okay, for example, suppose find cofactor matrix of A equal to 1, 2, 3, 4. Okay, so we know the cofactor matrix of 2 by 2 matrix is given by matrix capital A11, A12, A21 and A22. Okay, where this Aij is minus 1 raised to I plus j into Mij, where Mij is the minor of the element A11 or Aij. Okay, so firstly we'll find what is value for A11. This is minus 1 raised to 1 plus 1 into M11, and M11 is the minor of the element A11. So where is the A11 element? This one. So hide row and column. Okay, so what we get? Only 4. So this will be minus 1 raised to 2 into 4, which is equal to 4. Okay, similarly we can find this A12, which is minus 1 raised to 1 plus 2 into M12. Okay, this will be minus 1 raised to 3 into M12. Okay, and this M12 is a minor of the element A12. Okay, so this is the element A12. So hide row and the column where that 2 is present. Okay, what remains? 3. So what will be this into 3? Okay, and this will be equal to minus 1 raised to 3 is minus 1. This will be minus 3. Similarly, we can find A21, which is minus 1 raised to 2 plus 1 into M21, which is minus 1 raised to 3 into M21. M21 is the minor of the element A21. A21 element is this. So hide column and row. So what remains? 2. So write 2 here. Okay, so what this will be? Minus 2. Similarly, we can find A22. This will be minus 1 raised to 2 plus 2 M22. Okay, so this is equal to minus 1 raised to 4 into M22. M22 is the minor of the element A22. A22 element is this. Hide column and row. So what remains? 1. So this will be 1. Okay, so this is how we can find cofactor of every element, and so that we can find the cofactor matrix. Okay, so cofactor matrix, okay, which was what? A11, A12, A21, A22. Okay, and this is equal to A11 entry is 4, then minus 3, then minus 2 and 1. So this will be our matrix of cofactors. Okay, for example, again, suppose I want to find the cofactor matrix of 1 2 0 1 minus 1 3 1 1 5. Okay, so this is our matrix, and question is find cofactor matrix of matrix A. Okay, so obviously the cofactor matrix of A will be the matrix. Now this is the matrix of order 3 by 3. This will be A11, A12, A13. Okay, this will be A21, A22, A23. Then this will be A31, A32 and A33. This is the matrix of order 3 by 3. So we have to find cofactor of every element. Okay, means we need to find this Aij, okay, which is given by -1 raised to I plus j into Mij, where Mij is the minor of the element Aij. Okay, so firstly we will find A11, and A11 is what? -1 raised to 1 plus 1, and the minor of the element A11. Now A11 is here. Okay, so hide the row and column where that element is present and write its minor. Okay, so this will be the determinant -1, 3, 1, 5, and this will be equal to -1 raised to 2 in bracket. This will be -5 minus 3. Okay, so this will be -8. Okay, so we got the entry A11. Okay, similarly we can find the entry A12, okay, which is equal to -1 raised to 1 plus 2, okay, and into M12, which is equal to -1 raised to 3 into minor of the element A12. A12 is element this one, and its minor will be hide this column and the row. Okay, so whatever determinant we get, just solve that determinant, and the determinant will be 2, 0, 1 and 5. So solve the determinant -1 raised to 3, okay, which is -1. Okay, this will be -1, and into 10 minus 0, which is what? -10. Okay, similarly we can find the element A13, which is -1 raised to 1 plus 3 into M13, where M13 is the minor of the element A13. Okay, so here is the element A13. So hide row and column. So we get the determinant is equal to, this is equal to -1 raised to 4 into the determinant. Okay, determinant will be 2, -1, 0 and 3. So this will be -1 raised to 4 is 1. So what remains? 6 minus 0, which is 6. Okay, so we got all 3 entries in the row, first row. So we need to find the entries in the second row as well as the entries in the third row. Okay, so I will take this matrix on the next page. Okay, see what happens. Okay, now we need to find the entry A21, which will be -1 raised to 2 plus 1 into M21, which is -1 raised to 3 into the determinant of M21. M21 entry is here, so hide the row and the column where that element is present. So what remains? The matrix 1, 1, 3, 5, which is -1 raised to 3 is -1 into, this will be 5 minus 3, which is 2. So answer will be -2. Okay, and again we need to find this entry A22, which will be -1 raised to 2 plus 2 into M22, which is equal to -1 raised to 4 into the determinant of A22. Okay, A22 entry is here, so hide the row and the column. So whatever remains, that will be our determinant. Okay, so that will be 1105. Okay, so this is 1105. This is equal to -1 raised to 4 is 1. This will be 5 minus 0, which is 5. Similarly, we can find this A23 -1 raised to 2 plus 3 into M23. So this will be -1 raised to 5 into M23. M23 entry is this one. Okay, so hide the row and the column where that element is present, and the determinant will be 1103. Okay, so this will be determinant 1103, which is -1 into, this will be 3 minus 0. Okay, so this will be -3. Okay, similar way we can calculate this as M31, which is -1 raised to 3 plus 1 into M31, where M31 is the minor of the element A31. So this will be -1 raised to 4 into M31, which will be the determinant, by hiding the row and third row and the first column. So hide third row and first column. So we will get this entry, the minor for the element A31, which will be 1 1 minus 1 1. Okay, so this will be 1 1 minus 1 1. Okay, solving this will be minus 1 raised to 4 is 1, this will be 1 minus 1 is 0. Okay, then you can find the entry A32, and A32 will be minus 1 raised to 3 plus 2 into M32. Okay, minus 1 raised to 5 into M32, minor of the element A32 element is here, so hide this row and this column. So what remains? 2 1 1 1 2 1. Okay, so we get this as 1 1 2 1. So this will be minus 1 into 1 1 2 1. So this will be 1 minus 2, which is minus 1, into minus 1, which is 1. So finally we get this as final entry A33, minus 1 raised to 3 plus 3 into M33. Okay, and which is equal to minus 1 raised to 6, that is equal to 1. Okay, into, okay, this will be minus 1 raised to 6 into the determinant, and the determinant will be the minor of the element A33. So where is element A33? This one. So hide the row and column where that element is present. So what remains? 1 2 1 minus 1. Okay, minus 1 raised to 6 is 1, so this will be minus 1 minus 2, that is minus 3. So we got all the values for the elements in the cofactor matrix. So finally we can write our required cofactor matrix. Therefore the cofactor matrix of A is equal to, now the entry A11, A12 and A13 are the entries A11, A12 and 13 are, okay, minus 8, minus 10 and 6, minus 8, minus 10 and 6. Then the entry A21, A22 and A23. Okay, this will be minus 2, 5 and minus 3. Okay, and the entries A31, A32 and A33, that is 0, 1 and minus 3, 0, 1 and minus 3. And this is how we find the matrix, the cofactor matrix. Okay, now once you understood how to find the cofactor matrix, we can easily find the matrix, the adjoint of the matrix, okay, which will be obtained using the cofactor matrix. Okay, so we will see what means the adjoint of the matrix. Okay, adjoint of matrix. Okay, so adjoint of the matrix is basically, it will be obtained using the cofactor matrix, and how to obtain adjoint matrix using cofactor matrix, that we will see in the next lecture. Till then, goodbye.